Okay, so good afternoon to all. Again, the subject is digital fundamental. So in last lecture, we learn about the binary subtraction and binary division. So we covered two, three examples of the binary division. So there is a you can say no change between a decimal division and a binary division. It is similar. It is similar only. So as we are doing the division of the decimal, same way we have to do the division of the binary. Okay. So in last session we do the this example in which we have to divide a 101101 with a 110. So first we have to consider a 3 digit because the denominator we have a 3 digit. So the first 3 digit of the numerator is 101, and it is a less than a 110. So instead of first 3 digit of the numerator, we have to take the first 4 digit. So the first 4 digit is, you can say, 1011. So we have to take 1011 and divided by 110. So 110 into 1, it is 110 only. So if we subtract 1011 from a 110, we get the answer 101. Now again we have to, for the next division, we have to take a next bit downward. So 0 will come to the downward. So now it becomes 1010. And again we have to take divide 1010 with 110. So multiplied 110 with a 1, it gives 110. Now if you subtract 1010, or sorry, if you subtract 110 from a 1010, you get the answer 100. And again for the next term we have to take a 1 next bit to the downward. So it is a 1. So now it is 1001. Again 1001 is higher than 110. Same way we have to divide. So 1001, if you subtract 1001 from a 110, you get the answer 011, or you can say 11. Now all the bits are covered. All the bits are covered, and again we do not have we have the remainder 11. So what we have to take, we are putting a point and taking a 0. We are putting a point and taking a 0. So now it's 110. Again 110 into 1, it is 110, and last one it is 000. So this is the thing which we are covered in the last example. And also we done more two example for the division. Okay, so now the next topic is the signed binary numbers. The next topic is the signed binary numbers. Now what is the meaning of signed binary numbers? So it's very important thing. See, sorry, it's very important thing. Suppose what you are doing, if you are writing a 10 in your system, so it converts a 10, which is a decimal number, into a binary. So it is 1010. It is 1010. But again, suppose instead of plus 10, if you are writing minus 10, so how your system will be understand? Either you are writing plus 10 or you are writing minus 10. Either you are writing plus 10 or you are writing minus 10. So for that we have to use the signed binary numbers. So simply we have to give a sign to the binary numbers. We have to give a sign to the binary numbers. So how we can give a sign? So there are two methods or two ways by which we can give a sign to the binary numbers. Sign to the binary numbers. So the first method is sign magnitude form. So the first method is sign magnitude form, and the second method is known as the complement form. The second method is known as the complement form. So generally now we are focused on the complement form only, but I was give you the example about the sign magnitude form. In sign magnitude form, what we are doing, we have to I was already give you the example. Sorry. Suppose you have to write 10. So you are writing 10 in a system. So what your system does, your system doesn't understand the decimal number or octal or hexadecimal number. Your system, or simply you say the computer system will understand only a binary number system. So what it converts? It converts 10 decimal into a binary. So it is 1010. And instead of plus 10, if you writing minus 10, then also if you convert this decimal number into a binary, so the if you convert 10 into a binary, it gives you the answer 1010 only. So now how your system will understand that this number is positive or negative? This number is positive or a negative number. So for that we have two methods as already we see. The first one is the sign magnitude form. The first one is the sign magnitude form, and the second one is the complement form. Second one is the complement form. So our mainly focus on the complement form only, but how the sign form will work. So what it does in sign form, if you convert 10 into a binary, it gives you a 1010. So it will add extra bit which is 0. So what this 0 indicate? This 0 indicate that your number is positive. Your number is positive. And if you writing minus 10, so the number is remain same, it is 1010, but the system will add extra bit. So this bit, extra bit, this both the extra bit are known as the sign bit. 0 and 1, what is gives? It gives a sign of your number. So if it is 0, then what that means, your number is positive. And if it is 1, what that means, your number is negative. So this is the sign magnitude form. But now we have to focus on the complement form. So again, in a complement method, we have two different methods known as the ones complement and twos complement. Known as a ones complement and a twos complement. So how the ones complement and the twos complement method will work? How the ones complement and the twos complement method will work? Now let's see it. So first one is the first complement method. The first one is the ones complement method. It is known as the ones complement method. So how we can obtain a ones complement method? Suppose you have some number. Let's take again same example 1010, and you have to convert that 1010 into a ones complement. You have to convert that 1010 into a complement. So how will you do? Okay. So what you have to do, the number which you have, which is 1010, you have to subtract all the given binary numbers from a 1. You have to subtract all the binary numbers from a 1. So what we have to do, we have to subtract a 1010 from a 1111. We have to subtract 1010 from 1111. Then what my answer is? 1 minus 0 is 1, 1 minus 1 is 0, again 1 minus 0 is 1, and 1 minus 1 is 0. So my answer is 0, 1, 0, 1. Let's check the example. Suppose I have a bit 1, 1, 0, 1. I have to find its ones complement. I have to find its ones complement. So how can I find its ones complement? So I have to subtract each and every digit of the binary number from the 1. I have to subtract each and every digit of the binary numbers from the 1. So let's subtract all the digits of the binary given binary numbers from the 1. So 1 minus 1 is 0. Again 1 minus 0 is 1. Okay, this 1 minus 1 is 0. 1 minus 0 is 1. Again 1 minus 1 is 0 and 1 minus 1 is 0. Okay. So my answer is now 1 minus 1 is 0, as I already said. Then it is 1 minus 0 is 1. Then 1 minus 1 is 0. And last one, 1 minus 1 is 0. So the answer of the ones complement is 0010. Is 0010. Let's take another example. For the fraction also it will be same. From the fraction also it will be same. Suppose now we have the numbers 101.01, 101.01. Now again we have to subtract each and every digit of the given binary numbers from the 1. So again you can see here 1 minus 1 is 0. Then 1 minus 0 is 1. Again 1 minus 1 is 0. Again 1 minus 0 is 1. Again 1 minus 1 is 0. So this is the ones complement method. What we have to do, we have to subtract each and every digits of the binary number from the 1. But I will give you a short method. Suppose my example is here which we have 1 1 0 1. Now instead of subtract, do not remember the sub. It will be it we have to subtract from 1. What we have to do? Just invert all the digit. Just invert all the digit. What that means? Convert 1 into 0 and 0 into 1. So here I have 1, I am converting into 0. Here I have 1, I am converting into 0. Here I have 0 converting into 1. Here I have 0 converting into 0. So you check, both the answers are same. Both the answers are same. Again, take this example also. Suppose I have an example of fraction. It is, you can say 101.01. Instead of subtract, reverse all the digit, or simple invert all the digit. What what that means? Convert 1 into 0, 0 into 1. So here I have 1. Here I have 1. So I am converting that one into a 0. Then I have 0 convert into 1. Then I have 1 convert into 0. Point remain as it is. Again I have 0, I am converting into 1. Again I have 1, I am converting into 0. Check both the answer. It's same. So this is the short method to find the ones complement. Invert all the binary digits you have. What that means by invert? Simply convert all the ones into 0 and all the zeros into 1. Okay. Up to this ones complement. If anyone having any doubt, how to find a ones complement? Anyone having any doubt? Otherwise, we will move forward. Okay. And here I will give you the short form also. What is the shortcut? Invert the numbers from 0 to 1 and 1 to 0. Okay. Now, the next method is known as the 2's complement method. The next method is known as the 2's complement method. So, how the 2's complement will find? So, first, what you have to do, suppose you have any number. You have any number. Let me give you the example. Let's you have a number, same number we'll take 1010. Okay. And what you have to find? You have to find 2's complement. So for finding a 2's complement, first we have to find the ones complement of the given number. Ones complement of the given number. So how we can find ones complement? It's easy. Invert all the numbers. So 0, 1 into 0, 0 into 1, 1 into 0, and 0 into 1. Okay, so this is the ones complement of 1010, converting 1 into 0 and 0 into 1. Now what we have to do? We have to add 1. We have to add 1 to the rightmost bit. To the rightmost bit. Suppose if you example 1, sorry. Let me, I will, okay, we'll do another example which is 10.01. Okay. So first we complete this example. So what you have to do, For finding a two's complement, first you have to find the ones complement. First you have to find the ones complement, and how you can find the ones complement. Now it's clear for all of you. Convert 1 into 0 and 0 into 1. And now what we have to do, for by after finding the ones complement, we have to add we have to add 1 we have to add 1 to the rightmost bit. Now just do the addition. So 1 plus 1, it is 0. Here it is 1. 1 plus 1, 0, carry 1. So here it is 1, then 1 and 0. Okay. So now you get the answer. So this is the two's complement of the 1010. This is the two's complement of the 1010. Let me take another example. So the another example we have is 10.01. So again, what we have to do, first we have to find ones. So 0, 1 convert into 0, 0 into 1, 1 into 0, and 0 into 1 generally. So converting 1 into 0 and 0 into 1. So we have the ones complement. Okay. So for finding a two's complement, what we have to do, we have to add 1 to the last bit. We have to add 1 to the rightmost bit or the last bit. Either it is a fraction or it is an integer. Okay. So now 0 into 1, 1, again 1.1 and 0. So this is the two's complement method. Uh, let me show you how we can find the two's complement. Read the first line. Two's complement of a binary number is obtained by adding 1 to its ones complement form. Adding 1 to its ones complement form. So already we take the example. Take example again, 1100. So what we have to find first, the ones complement. In the PPT I will give you the common method which we have to use, but you can use shortcut only. How you can convert it? Convert 1 into 0 and 0 into 1. So your answer of the ones complement is 0011. But here what we have to do, we have to subtract each and every bit of the binary number from a 1. So answer remains same, 0011. So now what we have to do, we have to add 1 to the rightmost bit. So 1 plus 1 is 0, carry 1, 1 plus 1 is 0, again carry 1, so 1 and 0. So finally answer is 0100. Finally the answer is 0100. So this is the two's complement form of the 1100, which is 0100. Let's take another example, 101.01. Again, we have to find the ones complement, to subtract each and every digit from 1, or you can convert all the ones into 0 and all the zeros into 1. So you get the answer 010.10. 010.10. Okay. Now what we have to do, we have to add 1 to the rightmost bit. To the rightmost bit, either it is a fraction part or integer, do not consider it. To the last bit, we have to add 1. So this is the answer. 0 plus 1 is 1. Now all the other bits are remaining as it is. Now again there is a shortcut. Okay, what it is? Starting from right side, all bits are same. So starting from a right side, all bits are same till the first one occur, and then invert rest of the bits. I think uh, here there is some mistakes. So that will be checked afterwards. But how the two's complement find? We have to convert each and every digit from 0 to 1 and 1 to 0. So first we have to find the ones complement, and then we have to add 1. Then we have to add 1 to the last bit. Then we have to add 1 to the last bit. Now how we can representation? How we can represented negative numbers in a two's complement form? How we can represented a negative number in a two's complement form? Okay. So let's take the example. We have to express minus 65.5. We have to express minus 65.5 in 12-bit two's complement form. In a 12-bit two's complement form. Okay, in a 12-bit two's complement form. So first we have a number which is a decimal number. First we have a decimal number. So first we have to convert a decimal number into a binary number. First we have to convert that decimal number into a binary number. So we have 65, which is an integer part, and we have a 0.5, which is a fraction part. Okay. So how we can convert a decimal into binary? As we all know, we have to uh, divide the integer part with a 2, and we have to multiply the fraction part with a 2. Okay. So we have 65. So 65 divided by 2. It's actually 32.5, but we have to consider 32 only. So 32 into 2 is 64. So the remaining is 1. Again 32 divided by 2. So it is 16. So 16 into 2, 32. So remaining is 0. Again 16 divided by 2. So it's 8. So again remaining is 0. Again 8 divided by 2. So it is 4. So again remaining is 0. 4 by 2, it's 2. So again remaining is 0. So 2 by 2. It's 1, again remaining is 0. And now 1 by 2 it's not possible, so we have to take 1 as it is. So when we are converting into a, you can say, a binary, we have to write the answer from a bottom to top. We have to write the answer from a bottom to top. Now we have to convert a point 0.5 into a binary, so 0.5 into 2, so it's directly 1. So the result we have to write in a 12 bit. The result we have to write in a 12 bit. So how many bits we have actually? So 1, 2, 3, 4, 5, 6, 7, and this one is 8. So we have total 8 bit. We have total 8 bit. Okay. So we have to convert that into a 12 bit. We have to convert that into a 12 bit. So here I'm adding 1 0. So in a group of generally 4 4 we have to take. So group of 4 and 4, here it is 8, and this is a group of 4, so here it is 12. So now this is a positive number, but we have to convert this into a negative number. So how we convert? So for negative number, we require the answer. We have to convert this answer. We have to convert this answer into a, it's two's complement form. So here it will not show. Let me show you how we are converting the answer. Okay, so our answer is, this is our answer. Okay. See, the meaning of the complement is the reverse. The meaning of the complement is the reverse. Now, why it's ones and twos only? Because the binary number having only two digits, 0 and 1. So for binary numbers, we have a two's complement form and one's complement form only. Okay. And why it is used? The complement form is used for the representation of the negative number. A representation of a negative number. Suppose as a sign number, which is the one of the example I will give you, if you are writing a plus 10 in your system, so how your system will understand, either it will be a plus 10 or it will be a minus 10. So for that, what we are doing, we are adding 0 for the plus number and we are adding 1 to the minus number system. So there is one system in your, there is one program in your system which will work on that. It will check the first bit. If it is 0, then what that means, your number is positive, and if it is starting from 1, then your number is negative. Okay. So this is the answer, but now we have to convert into a 12-bit number. See, again, our system will work on either a 12-bit. Now, nowadays, your system will work as you see. Generally, your PC, then your PC work on a 32-bit or a 64-bit. Okay, so your system will work on a 32-bit or a 64-bit. Then how many bits we have? Only 8. Then we have to convert, or your system will convert this 8-bit or 5-bit into a 32-bit long number or into a 64-bit long number. Okay. So first we have to convert this number into a 8 or 12-bit. So what we have to do, I am adding 3 zeros. So here I have a group of 4. Now I have a group of 4, and again I am adding another 0. So now the total bits are 12. Now the total bits are 12. So what we have to do now, this is the answer of positive number. This is the answer of positive number, which is 65.5. But we have to write the answer minus 65.5. We have to write the answer minus 65.5. So what we have to do, we have to convert the number into its 2's complement form. Into its 2's complement form. So how we can convert? First we have to find the 1's complement. So how we can find the 1's complement? Simple method, convert all the zeros into 1's and all the 1's into zeros. So my answer is 1, 0, 1, 1, 1, 1, 1, 0, point, 0, 1, 1, 1. So this is the 1's complement form. And how we can find the 2's complement form? So we have to add 1 to the rightmost bit. To the rightmost bit. So now do the addition. As you know, 1 plus 1 is 0 with a carry 1. Again 1 plus 1 is 0 with a carry 1. Again 1 plus 1 is 0 with a carry 1, and now it's 1. And all the numbers now it is the same. So 0, 1, 1, 1. So now this number represents minus 65.5 in the 2's complement form. In the 2's complement form. So this is the answer, 10111110.100. So this is the answer of minus 65.5 in its 2's complement form. Okay, so that's how we can represented a negative number into its 1's complement form, or you can say into its 2's complement form. Now as we have a 1's complement and 2's complement, as we have a 1's complement and a 2's complement for a binary number system, same way we have a 9's complement method and 10's complement method for the decimal number system. Same way, we have a 7's complement method and 8's complement method for the octet number system. Okay, and generally for hexadecimal, we are not using even because hexadecimal numbers are mostly never used in any system. But generally, in our syllabus, we have a 1's complement and a 2's complement, as well as we have a 9's complement and 10's complement. So the first, again, 9's complement and 10's complement. See why it will work. Complement method, you will understand it later. Generally, suppose if you want to uh, subtract two numbers, then we required a separate hardware for subtraction. If you want to add two numbers, then you required a separate hardware for the adder. Okay, but by using a complement method, if we are using a complement method, okay, how it will work that you will understand later, but I will just give you the information. If you are using a complement form or a complement method, then we do not require any hardware for the subtraction. Then we do not require any hardware for the subtraction. By using the hardware of a adder only, we can subtract two numbers. And how it will do, that we'll learn later. But why the complement method is useful? It reduces your hardware from the system. It reduces your hardware. Okay, again I am saying, for the adder you require a separate adder hardware. For subtractor you require a separate subtractor hardware. But by using a complement method, we are eliminating the requirement of the subtract hardware. By using a adder hardware only or addition hardware only, we can do the subtraction. We can do the subtraction. Now, how it will do that we'll again learn later. But now again, a method is known as the 9's complement and 10's complement method. So when it will be used, the 9's complement and 10's complement method, a 9's complement and a 10's complement method is used for the decimal number system. So how we have to convert a 9's complement? Simply, what we have to do, you have some decimal number. You have to subtract all the bits, all the digits of the decimal number by from the 9. You have to subtract all the digits, all the given digits from the 9. Okay. So read the first line. It is nice complement of a decimal number is obtained by subtracting each digit of the decimal number from the 9. Each digit of the decimal number from the 9. Okay. So we have one example which is 3465 and we have to find its 9th complement. What we have to do, we have to subtract each and every digit from the 9. So you subtract it. So 9 minus 5, it is 4. 9 minus 6, it is 3. 9 minus 4, again it is 5. 9 minus 3, it is 6. So the ninth complement of the 3465 is 6535. 6534. 6534. Now let's take another example. Suppose I have a 782.54. Again, what we have to do? We have to subtract. We have to subtract each and every digit of the given decimal number from the 9. So again, 9 minus 4 it's 5, 9 minus 5 it's 4, 9 minus 2 it's 7, 9 minus 8 it's 1, and 9 minus 7 is 2. So this is the ninth complement method of 782.54. 782.54. So that's how we can find the ninth complement. That's how we can find the ninth complement. Just subtract each and every digit of the given decimal number from the 9. Same way we have tens complement. Okay, tell me how we can find the twos complement. How we can find the twos complement? First, we have to find the ones complement. First, we have to find the ones complement, and then what we are doing? Then we are adding one. Then we are adding one to the last bit. Then we are adding one to the last number. So same thing we can use for the tens complement method. So for finding a tens complement method, first we have to find the nines complement for the given number. First we have to find the nines complement of a given number, and then we have to add one. Then we have to add one to the last number. So this is the rule. The tens complement of a decimal number is obtained by adding one to its nines complement form. To its nines complement form. So let's do the example. So same example, suppose 3, 4, 6, 5. But now I want to find the you can say the tens complement instead of nines complement. We have to find the tens complement. So how we can find the tens complement? So again we have 3, 4, 6, 5. So first we have to find the nines complement of a given number. So how we can find the nines complement? Subtract each and every number from the 9. So now you have a nines complement. So 9 minus 5 is 4, 9 minus 6 is 3, 9 minus 4 is 5, and 9 minus 3 is 6. Okay, now what we have to do? For finding a tens complement, we have to add 1. We have to add 1 to the last number. We have to add 1 to the last number. So I am adding a 1 to the last numbers. So 4 plus 1 it is 5. Remaining ones it is as it is. So that's how we can find the tens complement. That's how we can find the tens complement method. Let's take another example. So we have 782.54. Again, we have to find the tens complement. So how we can find the tens complement? So we have to subtract each and every digit from a 9 to find the nines complement first. And for finding a tens complement, what we have to do? We have to add 1 to the last bit. We have to add 1 to the last bit, or you can say we have to add 1 to the rightmost bit. So here I am adding 1. So 5 plus 1 is 6. All the remaining bits are remain same. All the remaining bits are the remain same. Okay, so this is the tens complement of the 782.54. 782.54. Now the next one is the subtraction using nines complement and tens. Okay, let it be. This will be, we will be taking the next lecture because it will take a time. Because there are some rules, and the rules you have to remember. If I tell you about this today only, you again forgot it. So now up to this, for a ones complement and for a twos complement. If anyone having any doubt, they can unmute themselves and ask me a question, or you can ask me a question in a chat session. Ones complement, twos complement, nines complement, tens complement. Anyone having any doubt regarding this? Okay. So only I got the reply from the Mohit. What about others? Either it is clear or not. Okay. Because it's very easy, but now the subtraction using nines and tens and the subtraction using ones and twos having different rules that you have to remember. Okay. So Monday we will do the subtraction by using tens complement and nines complement. Yes, so that's why we have only 3 minutes left. That's why I will not start the new topic. So now there is no doubt. Assignment, but let me share with you because here we have a theory session. So this is your assignment number 1. Okay, I will upload it today in a Canvas portal. So you download it from there, and you have to write the answer. And it's difficult to copy paste. Some of the example you have to do by yourself only, because see, the first question number 1 is do as directed, or simply it is nothing but a number conversion, which we already covered. A conversion. I will upload a PPT, and you can say this my lecture note also. So from there you can, if you have any doubt, you can solve from there. Okay. So this is a first question. What is it? You have to convert a decimal number system into a binary. But here I am not giving you a decimal number. See, instead of decimal number, what you have, a ddmm.mm. What that means? It's your date of birth. So each and every student, what they have to do once they start the writing the assignment, they have to write their date of birth on a first page and their enrollment number a full enrollment number in the first page. Okay, suppose let's our example today is the 3rd September. So anyone having a birthday of 3rd September. So it is the date is 03 and a 09. So what's your example is 0309.09. So that's how you have to solve the example. So I will upload it, the assignment today only. And if anyone having any doubt, they can ask me the question. So now please write down the number. Yes, I will upload the soft copy also. 1 to 10. Henil is the first who write the number every time. From 1 to 10 only I am saying. 11 to 20. Between 11 to 20. Okay, 15. 21 to 30. Okay. 31 to 40. 40, 33, 37, 23. I have 39. Okay. And then 41 to 50. 41, 45, 48, 43, 42. 51 to 60. 59. Only 59. Okay, 61 to 70. Okay, 52, 55, 57, 60, 61, 62, 64, 66. 71 to 80. Okay. 81 to 90. Okay. 91 to 100. 90 to 99. Only I have two. 101 to 110. Okay. 7, 9, 5, 10. Then 11 to 20. 11. Okay. Now the remaining. So thank you everyone for attending a session. If you have any doubt anytime, you can send me your doubt in my WhatsApp number, or you can also call me anytime. Okay, 94 and 93 now, right now we have. So so those who write their enrollment number, if they want to leave, they can leave the session. So thank you everyone.